Hello, in this video I'm going to try and explain using simple words what the Standard Model of particle physics is. So the Standard Model is a theory that describes the interactions between the fundamental particles in nature. By fundamental we mean a particle that so far cannot be broken down into other components. So we just assume that it is not made of anything else. So in the Standard Model we have these ingredients here. We have the electron, the muon, the tau, and for each one of them there's a corresponding neutrino. So the electron neutrino, the muon neutrino, and the tau neutrino. Those 6 particles together are known as leptons. Besides leptons, the Standard Model includes quarks. So we have the up quark, the down quark, the charm, the strange, the top, and the bottom quark. And those are the 12 fundamental particles in nature we know so far. Everything in our everyday world is made of those particles. Now, besides those particles, the Standard Model has a few other particles that are known as bosons. We have the photon, the gluon, the W, and the Z boson. Now, those bosons here are known as vector bosons. Now, the photon is responsible for the electromagnetic interactions that take place between any charged particles, that is, all of those particles besides the neutrinos. The gluon is responsible for the strong nuclear force, that is basically interactions between quarks, and the Z and W bosons are responsible for the weak nuclear force, and that's basically, those can actually interact with all those particles. In addition, we have the newly discovered Higgs boson. This is a scalar boson, unlike the others, and I'm just going to come back to this. Now, the Standard Model just has those ingredients here, so a total of 17 particles, and it describes how those particles interact with each other. Please note that the Standard Model does not include gravity, so sometimes it is referred to as the theory of almost everything. Okay, let's talk a bit more about those particles. The leptons here and the quarks are fermions. Fermions are particles which have integer spin. So in this case, all 12 particles of them have spin half. In this case, vector bosons have spin equal to 1. Boson is a particle with an integer spin. And the Higgs has spin equal to 0. That's why it's called scalar. So the photon can interact with any charged particle. That is, as we said, that is electron, muon, tau, and all the quarks. Those particles here have charge of -1. The neutrinos have no charge. The up, the charm, and the top quark have a charge of +2/3. The down, the strange, and the bottom have a charge of -1/3. So the photon can interact with all of those besides the neutrinos. The gluon interacts only with the colored charge. Colored charge is only carried by quarks, so just quarks. While W's and Z interact with a weak hypercharge, or you can just assume that they interact with all of those particles. Now, the Higgs boson interacts with anything that has mass, basically coupled to anything that has mass. So again, with all those particles except the neutrinos. I know the neutrinos were shown to have a very, very, very small mass, but not zero. However, in the standard model, the neutrinos are assumed to be massless, and the Higgs boson cannot explain how they get their mass, so chances are there's another mechanism behind it. So this is the standard model and its ingredients. Thank you for watching.